Good day everyone. So welcome to our Math 104 class. This is a plain and solid geometry subject. So the one who prepared this video presentation is by yours truly, Ms. Jana Rose Rivera, together with Mr. John Mark Rivera. So for today's video, we will be discussing about the polyhedron and also the Euler's formula. So let's see first what is a polyhedron. So a polyhedron is a three-dimensional shape with flat polygonal faces, straight edges, and sharp corners or vertices. So here are the common examples of a polyhedron. We have here a cube, triangular prism, hexagonal prism, and also the pentagonal pyramid. So the parts of a polyhedron are classified as faces, edges, and vertices. So I provided the figure here. So you can see it clearly where is the edge, the face, and also the vertex. So to dig deeper, we can read their definitions. So here are the parts of a polyhedron. So the polyhedron faces. So this is the flat surfaces of a polyhedron and termed as its faces, which are basically polygons. The second one is the polyhedron edges. So these are the edges, are the line segments where two faces met. The third one is the polyhedron's vertices, which is the point of intersection of two edges is known as a vertex. So polyhedrons also can be broadly classified as prisms, pyramids, and platonic solids. Let's understand each type. So as you can see here, there are different types of prisms, pyramids, and also the platonic solids. So let's know what is the prism. What is prism? So a prism has its both ends, base and top, as identical polygons, and its side faces are flat, rectangles or parallelograms. Prisms are named after its base, which can be a triangle, square, rectangle, or any n-sided polygon. So here are some of the examples of a prism. We have here triangular prism, square prism, pentagonal prism, rectangular prism, hexagonal prism, octagonal prism, and also the trapezoidal prism. The second one is the pyramid. So a pyramid has its base as any polygon, and its side faces are triangles with a common vertex, known as apex. If the base of a pyramid is an n-sided polygon, then it has n plus 1 faces, n plus 1 vertices, and 2 n edges. So here are some of the examples of a pyramid. We have here triangular pyramid, square pyramid, pentagonal pyramid, and also the rectangular pyramid. So let's proceed to platonic solids. So in platonic solids, all the faces are congruent, regular polygons, and the same number of faces met at each vertex. So we have here some examples of platonic solids: the tetrahedron, cube, octahedron, dodecahedron, and also the icosahedron. So examples in real life of a polyhedron. So we can observe several polyhedra. Polyhedra is a plural of a polyhedron in our daily existence, such as Rubik's Cube, dice, bulky ball, pyramids, and so on. A diamond is one of the real examples of polyhedron. So here are the types of a polyhedron. We have here the regular and the irregular polyhedron. So polyhedra are mainly divided into two types based on the polygonal faces in the base: regular polyhedrons and irregular polyhedrons. Platonic solids are regular polyhedrons. Prisms and pyramids are irregular polyhedrons. So you need to remember this: platonic solids are regular polyhedrons. Platonic solids are regular polygons. Prisms and pyramids are irregular polyhedrons. So, regular polyhedrons are made up of regular polygons. They are also known as platonic solids. They have all their faces, edges, and angles congruent. The following is the list of the 5 regular polyhedrons. So, we have here the name, also the image, and also the properties. So, the name is cube. So, cube has 6 faces, 12 edges, and 8 vertices. The shape of each face is a square. The next one is the tetrahedron. So, it has 4 faces, 6 edges, and 4 vertices. The shape of each face is an equilateral triangle. So, the third one is the regular octahedron. So, it has 8 faces, 12 edges, and 6 vertices. The shape of each face is an equilateral triangle. The fourth one is the regular dodecahedron. So a regular dodecahedron has 12 faces, 30 edges, and 20 vertices. The shape of each face is a regular pentagon. The last one is the regular icosahedron. So a regular icosahedron has 20 faces, 30 edges, and 12 vertices. The shape of each face is an equilateral triangle. So we have here the definition of a irregular polyhedron. An irregular polyhedron has polygonal faces that are not congruent to each other. It has made up of polygons having different shapes, so all its complements are not the same. So we have here some examples of an irregular polyhedron. We have here hexagonal pyramid and also the pentagonal prism. So let's proceed to Euler's formula. So polyhedron and Euler's formula is interconnected. So let's find out. So there is a relationship between the number of faces, edges, and vertices in a polyhedron, which can be represented by a math formula known as Euler's formula. So here is the Euler's formula. The F, which is the faces, plus V, which is the vertices, minus E, which is the edges, equals 2. So, if we know any two values among F, V, or E, we can find the third missing value using Euler's formula. So the questions like, how many edges does a polyhedron have? Or how many faces does a polyhedron have? Can be answered easily if the other two values are known. We can also check if a polyhedron with a given number of parts exists or not. So, Euler's formula is really important if we need to find out if the figure is a polyhedron or not. So, for example, we have here a problem. A cube has 8 vertices, 6 faces, and 12 edges. So, we have all the given. The faces is 6, vertices is 8, edges is 12. So applying Euler's formula, we get F plus V minus E equals 2. Substituting the values in the formula, F is 6, V is 8, minus 12 equals 2. So 6 plus 8 equals 14, minus 12 equals 2. So 14 minus 12 is 2, then equals 2. So all sides are equals. So we can conclude that, hence, the cube is a polyhedron. We have another example. How many faces does a polyhedron with 12 vertices and 18 edges have? So we are tasked to find the faces. So F is unknown, vertices is 12, edges is 18. So applying Euler's formula, we get F plus V minus E equals 2. Substituting the values in the formula, F plus the vertices, which is 12, minus 18 equals 2. F minus 6 equals 2. F equals the negative 6 transposed to the other side of the equation, it will become positive. So it will become 6 plus 2. The number 2 is just remain since hindi naman natin siya nilipat. So we have here the 6 plus 2. So our faces is 8. So we can conclude here that hence the number of faces is 8. Let's proceed to the last example. Check if the polyhedron with 10 vertices, 8 edges, and 4 faces exist or not. So, we can put the indicated value. So the faces is 4, the vertices is 10, the edges is 8. So applying Euler's formula, we get F plus V minus E equals 2. Substituting the values in the formula, the faces is 4 plus the vertices is 10 minus the edges is 8 equals 2. 4 plus 10 equals 14 minus 8 equals 2. 14 minus 8 is 6 equals 2. So the equation is not equal. So we can conclude here that hence the polyhedron with the given dimensions does not exist. So thank you everyone. I hope that you learned something today. Thank you for listening. Bye-bye.